All right, we're ready to start section 8.6, winding this course down. Only one more section after this. I did break 8.7 into two parts, A and B, so they'll be separate video groups, but only two sections left in the book for us. So in this section, we're going to learn about the irrational number e and the change of base formula. And you may remember back when we were first learning logs in 8.4, I said there were two types of logs. This log, which we usually don't put a base on, is base 10. And when you see natural log, it is base e. And you can see above its inverse is 10 to the x, its inverse is e to the x. So a regular log with no base written is base 10, and in this section we're going to learn about the natural log, which has a base of e. So what is e? That's what a lot of students don't understand when they start this section. I've never heard of e, they tell me. Well, e is an irrational number. That means it doesn't terminate or stop, and it doesn't repeat. It's just like pi. It's a universal constant. So pi is not a variable. It's a universal constant, which means it's a number. It goes on forever, so we call it an irrational number. So when I type pi in the calculator, see how it fills up the whole screen and there's no repetition? That means it goes on forever. When I type e in the screen, and e is above ln, so I do second ln, and I just say e to the first because that's what e is. I see it fills up the screen, 2718281828. So that is e, and it just keeps on going forever. And you know that whenever it fills up the screen. So here they're showing you 2718281828. So that's e. Just like pi, goes on forever, doesn't repeat. So how do we graph it? Well, we just pick some numbers for x. This isn't a log that we're graphing. So because it's not a log, we're not limited by what we can pick. We're graphing the exponential e to the x. So we can do a standard t-table if we like. We can do -2, -1, 0, 1, 2, and e to the third is going to be too big. So let's make this one -3. I didn't realize there was an extra spot there. Otherwise, I would have started with -3. In my head, I'm going, well, it's about 3, and 3 to the third is 27. So that's why I didn't put the +3 in. So when they're logarithms, remember how we filled y in first? When they're exponentials, we fill the x in first. And these are exponentials. The word log is nowhere to be found. So that's why we filled in the x's first. So this is going to be e to the -2. And we'll plug that in a bit. And let's put squigglies, because we know we're going to have to round it off, because if e goes on forever, then e to the -2 is going to go on forever too. And then this one's going to be e to the -1. We'll do the approximate symbols. E to the 0th. Ooh, what's anything to the 0th power? 1. So that one we don't even need a calculator. E to the first. Oh, we don't need a calculator for that either, because isn't that right here? So when we're graphing, we can really just do about one decimal place. So let's do our squigglies to show we're rounding. So that would be about 2.7. So we got 2 of them done. And then we'll have e to the second, which is approximately, and e to the -3rd, which is approximately. So again, we have the approximate symbols because we're going to be rounding on every single problem. So we can start with second ln, that produces the e, and then it says, hey, what exponent do you want me to plug in? So we'll plug in -2 first, close the exponent. So rounded to 1 decimal place, that would be about 0.1. And then we have to do e to the negative 1, so we can use our up arrow and just change the 2 to a 1. So that's about 0.4 if we round to 1 decimal place, because we can't graph more exact than 1 decimal place. So e to the second, whoa, yikers. Okay, let's hit the up arrow. Let's do -3 first since it's right there. And that's going to be 0.05. We couldn't round it to 1 decimal place because it would have been 0. So 0.05, which is just barely above 0. And now let's do the up arrow. We'll delete the negative and we need to change it to 2. And that's about 7.4 rounded to 1 decimal. So that's how we graph exponentials. We just put it into the calculator, or if it's not an irrational base, then we can do it in our head like we did back in 8.3 was the exponential section, I believe. Okay, so I don't know what else you remember about exponentials from 8.3, but they have a horizontal asymptote. Remember how logarithms had a vertical asymptote? We learned that exponentials have a horizontal asymptote, and if it hasn't been moved up or down, which it hasn't, there's no +1 out here or -2 out here, that means its horizontal asymptote is going to be y equals 0. So you might have to look back at 8.3 just to refresh your memory. So exponentials have a horizontal asymptote at y equals 0 unless there's a +1 added out here or -5 or something to that sort. Like this one, it's still going to be x equals 0 because this is, y equals 0, because this is with the x, meaning it's moved left or right. It hasn't been shifted up or down. So it will still have the y equals 0 asymptote as well. Okay, so let's graph this. So -2 goes with 0.1, which is just barely above the x-axis. -1 goes with 0.4, which is almost halfway. 0 goes with 1. That was another thing we learned about exponentials. If they haven't been moved up or down or left or right, 0, 1 will be on every graph. And then 1 goes with 2.7, which is a little bit more than 2.5, right underneath 3. 2 goes with 7.4. Oops, looks like we're going to have to add 1. 7, 8. Let's make that 8. So 2 goes with 7.4. There's 7, so 7.4 will be about right there. We can get this next one and then we'll have it. So -3 goes right above 0. So it's just a tiny bit lower than the point beside it. So do you see your exponential graph? And remember, when the base is greater than 1, that means it's a rising function, increasing function, because it rises from left to right. So we call this an increasing function, and that's because its base e is greater than 1. So let's do this part of it. And remember, it just rises really quickly on the right, has an arrow. And then this piece just floats right along the x-axis but never crosses it. Gets closer and closer to it, but it never crosses it. And it also gets an arrow on the end because these graphs go forever in both directions. So on the final and on the test, I ask you for domain and range. So let's go ahead and do those for these two problems. So domain, left forever, and here's an arrow showing it goes right forever. So like every other exponential function, the domain is -infinity to +infinity. Remember, it's left to right. The range is bottom to top. And I believe this is the second to the last or third to the last problem on the final is graphing an exponential stating the domain and range. So scrolling up, what's the lowest y value? Well, it doesn't quite hit 0, but it gets close to it. So because it can't hit 0, which we saw, it can't be equal to 0, it's going to get a parenthesis instead of a bracket. And then to the top, it goes all the way up to infinity. So that is the domain and range of every exponential that hasn't been moved left or right, up or down. And again, you can look back at 8.3 and see, kind of review that if you've forgotten. Okay, so let's go ahead and start this next one. So this time let's be smart and do -3, -2, -1, 0, 1, 2, since 2 to the second is going to be really big. Yeah, so is 2 to the third, so maybe we should do more. Maybe I'll make this one -4. Because this is going to be 2 plus 2, 2 to the fourth, which is 2 times 2 is 4 times 2 is 8, 16, so we'll be off the graph. So I'll go the other way instead. So if I see the numbers are getting too big, then I just go the other way. So this is going to be e, let me get a little more delicate pen, to the -3 plus 2, which is e to the -1. And we can look up above for that. E to the -1 is 0.4. So let's write 0.4 there. I'm going to make this smaller so that we don't have to keep going up or down. Let me focus. There we go. Maybe a little less bright, huh? Okay. So put a -3 up there. -3 plus 2 is -1. E to the -1 we already found is 0.4. Next we have -2 in there. E to the -2 plus 2 is e to the 0th, and we know anything to the 0th power is exactly 1. So we don't need our little approximate symbols because e to the 0th is exactly 1. No rounding there. Next we put -1 in, so we get e to the -1 plus 2. That would be e to the first, and we saw up here e to the first is 2.7. Approximately 2.7. And then we put in 0, e to the 0 plus 2 is e to the second, which in the t-table above is approximately 7.4. So we know after that it's going to be off the graph. So let's make these -4 and -5 because e to the third is going to be, like I said, like 27. So we'll go to the other way. So if your positives make it too big, then tack on a couple negatives at the end. So this will be e to the -5 plus 2, which is e to the -3. That one I don't think we've done yet. Oh, yes, we did, which is about 0.05. So -5 plus 2 is -3. -3 is approximately 0.05. And then last, e to the -4 plus 2 is e to the -2. And we have that one up above too. It's approximately, oh, there it is up there. So e to the -2 is approximately 0.1. And if you were typing it in, just FYI, so I want to make sure everybody knows how to type it in because you might not have one to look at. You do second E, like I showed you before, but now you're going to have two things in parentheses. So you type -4 plus 2, then close it. And that gives you your 0.1. So you got to make sure you include both of those in your